Joshabraham. What's with the background turning off? Mm-hmm. Uh, we're back with the chemistry for 1 hour. You might be thinking, why is he doing chemistry for 1 hour? I am testing my limits. How much progress I can get within 1 hour. If you are not if you are not that good at studying, you gotta do shit like these. So, yeah. What was it? No, general chemistry. Oh. So last time, where was I? Where was I last time? So electron domain means how many suborbitals left in the valence orbital. Now, valence orbital, what I meant by valence orbital was the outermost orbital, or, the principal quantum number. Orbitals that include in the principal quantum number of the outermost shell. Hey Siri, set a timer for 30 minutes. 30 minutes. 30 minutes. Pi bond, sigma bond, okay. Now I kinda understood the sp hybridization. Now explain how the pi bond works or forms using the orbitals. I need to know both double and triple bond, like how the pi bond works. Sigma bond versus pi bond key distinction. Head-on overlap along the internuclear axis uses hybrid orbitals. Stronger pi bond side-by-side overlap. Electron density above and below the pi bond axis uses pure unhybridized p orbitals. Weaker double bond sigma plus 1 pi. Example C to C 18. Step-by-step orbital picture. Each carbon is sp2 hybridized. I'm a bit confused on that part, because Where's carbon? We got carbon 6, right? 2, 2, 4. P orbital got 2. So we shift 1 from the 2s to p, resulting in 4 sp2 orbitals. How? 3 sp2 orbitals form sigma bond. Uh-huh. You need 3 to form sigma bond? One unhybridized p orbital left. Okay, let's take the example ET, then ether, ethane, ether. No, not ether. Ethine, yeah, ethine. I forgot. Let me get my headphones. Where are my headphones at? So, from what I understood, the carbon would be having 4 sp3 unhybridized orbital. Could you explain again why it's sp2, then sp3? Hybridization is equal number of electron domains around the atom. Oh, it changes. Okay. I press study, right? CC18, focus on one carbon. Carbon has 3 pi bonds. Sigma bonds. Hydrogen, okay. Uh-huh. 0 lone pairs, total electron domains 3. sp2 hybridization. Get this shit right, boy. Ooh, did I just poke? I did not mean to, bro. I did not mean to. Uh, could you explain here when carbon has 3 sigma, it results in what? Results in what? Hybridization is not about electrons, it's about orbital geometry. Atoms reshape their valence orbitals so that pi bonds are far apart as possible. Overlap is maximized, energy is minimized. So the atom, how many pi directions do I need? What a pi bond requires. A pi bond, one orbital directly at the other atom. Y pure S and P 1 to s orbital and 2 p orbital, 90 degrees at each other. P orbitals are 90 degrees apart. Using pure orbitals with given uneven bond strength. Okay, nature does not allow this. What sp2 hybridization actually is. Carbon mixes 2s and 2p orbitals. Y2 2p. Three equivalent arranged 120 degrees apart. CH4, we got 4 sp3. Therefore, okay, depends on the bonds. The remaining 1p orbital Which p orbital is untouched? Before hybridization, carbon has 3 p orbitals. Does matter which label? Yeah. Okay. When it's triple bond, then the p orbital overlap case also or it could doesn't matter or it doesn't matter the each carbon is sp hybridized. Okay. Hybridization uses each carbon is an sp hybridized. Hybridization uses 1s 1p forms 2 sp orbitals. Left over 2 unhybridized p orbitals on each carbon. Geometry defines everything. The sp orbitals lie along the straight line. They form one sigma bonds to the other atoms. Now the key point, the two remaining p orbitals must be perpendicular to the bond axis. They must be perpendicular to each other. Each carbon is sp hybridized. Hybridization uses 1s 2 unhybridized p orbital in each carbon. Geometry defines everything. Each unhybridized p orbital overlaps sideways with the matching p orbital on the other atom. So, like this, I'm guessing there is no d orbital or f orbital overlap. D is having correct for ordinary covalent multiple bonds. This is not a guess it's a core principle. Why SNP are used higher in energy for light elements. Using them for bonding would be energetically unfavorable. Nature always chooses lowest energy orbitals available. They physically cannot use d orbitals because n equals 2 shell has only S and P. What about period 3 and beyond? This is where confusion usually starts. Old incorrect explanation expanded octet because d orbitals participation. Modern correct explanation. D orbitals do not form normal covalent bonds. Hypervalence is explained by electron delocalization of 3 center 4 electron bonds. Molecular orbitals. So even the bonding is not PD overlap in classical sense. Transition metals, metal ligand bonding, crystal field, ligand field theory, d pi back bonding, d pi back bonding. Okay, there is something. They do not matter in CC. Okay, example safe. Comparison of single, double, and triple bond. Electron density perpendicular to the axis between the two nuclei. Axis of bond lies in the nodal plane. So I need on the axis of bond lies in nodal plane. I thought the axis of bond is parallel to the sigma bond, even though electron density is gonna be low at the center of the distance between the two p orbitals that overlap to form covalent bonding, delocalized bond. That's where, okay. Bond combination, n atomic orbitals, n molecular orbitals are formed. Okay, let's carefully unpack this. It can be confusing because the pi bond behaves differently from the sigma bond. Pi head-on overlap electron densities along the internuclear axis. Rotation is possible around this bond. Sideways overlap electron density is above and below the plane of the nuclei, cannot freely rotate without breaking the bond. What axis of bond lies in the nodal plane means when the nodal plane here is the plane where the electron density is 0. For pi bond, the internuclear axis connecting the two passes through the center of the overlap, but electron density is not through the axis. Instead, the density is above and below the axis. That central plane along the nucleus is the nodal plane where probability of finding the pi electrons is 0. Okay, I get it. rotation restriction because the electron densities above and below rotating one atom relative to the other breaks the sideway overlap, so pi bonds are rigid. Key takeaway: sigma bond along the axis, electron density perpendicular to the axis. Okay. The next part looks like molecular uh, orbitals and some explanation upon sigma star. Mm, Subtraction, addition, bonding, anti-bonding. The anti-bonding is not present. Okay. This is the core idea of molecular orbital theory. Let's break it down step by step so it's clear and exam ready. Formation of molecular orbitals: when two atomic orbitals from different atoms combine, they form two molecular orbitals. When two atomic orbitals from different atoms combine, they form two molecular orbitals, bonding, lower energy stabilizing, anti-bonding, higher energy destabilizing. Example: H2 molecule. Each H atom has one s orbital, total of two electrons. Linear combination of atomic orbitals: one is one is one plus one is two is sigma sigma one s plus minus antibonding electron filling. Two electrons go to bond order single bond. Two minus zero. Mm-hmm. Dude, it's one more minute. 30 minutes. Stupid. Let's start this with some examples, cause I feel like it's a lot to take in or keep. So I have two examples of H and HE with H having no and while HE has. Could you explain what's going on? Bond order half of 2 minus 2, 0. That's what makes H2 not exist, okay? Molecular orbitals, lithium. So we're talking about lithium 2. Bonding is mainly governed by 2s orbitals. So lithium, it's 3. It's 30 minutes. Fuck you know. No, okay, no, I'm not out of do that. Don't fall for money, Josh. Don't fall for money. Uh, the each H atom has one electron in the 1s orbital, 2 electrons in total. Combine 2 1s orbitals. You got 2 molecular orbitals. Yes. Filling the electrons, 2 electrons go. Filling the electrons, 2 electrons go into sigma 1s. Bonding orbitals fill, anti-bonding remains empty, bond order. So H2 exists as a stable single bond. Only bonding orbitals has electrons, stable molecule. Only bonding orbital has electrons. Each He atoms 2 electrons in 1s, 4 electrons total. Combined orbitals, same molecular orbitals, sigma 1 bonding, anti-bonding, filling the electrons. Bond order 2 minus 2. Both bonding and anti-bonding. Okay, key idea. I understand that anti-bonding. If you fill in the anti-bonding. Okay. Okay, but does this anti-bonding orbital exist across the whole periodic table? Also, is this anti-bonding orbital that results in a noble gas to not react with itself or others that much. I'm guessing it's the anti-bonding orbital. Yes, anti-binding orbital exists for all molecular orbitals formed by the combination of atomic orbitals. Whenever the two atomic orbitals combine, you get bonding orbital. Anti-bonding is concept is universal across periodic table of the molecules. Noble gas like helium, neon have filled atomic orbitals. If you give it to form electrons occupy bonding and anti-bonding. Okay, interesting. This anti-bonding. Anti-bonding. So, an example I got for the exam was so. Example I got was NO. Could you explain how the bonding goes in NO? Also, should I consider the anti-bonding every time I use the Aufbau diagram? The 2s orbitals are lower in energy than the 2p orbitals, so both molecular orbitals from 2s are lower in energy. What? Overlap of 2p orbitals, 2pz. Why is z mentioned? Is greater than the overlap of 2px and y. What? So the energy of the bonding sigma 2p is lower than that of anti-bonding sigma 2p. Is 2p is higher than that of this pi and pi star 2p molecule. So yeah, atom always prefers the lower energy state, right? Both pi and pi star are doubly degenerate. What do you mean? Here, no interaction between 2s orbitals of one atom and 2p of the other atom is considered. That is always not the case. Okay, that is always not the case. Here, there's no electrons mentioned. Okay. We got the 2p. So you form the sigma pi. Okay, pi star. So we got a 2p 2p overlap. To the wasteland, to the highways, and now will. It's 30 minutes, right? Oh shit, I gotta work out. I emptied a lot the storage. Yeah, boy. Fucking hell, Credilia. Mm-hmm. What the fuck? Yeah. Yeah. Push ups. You should always consider both anti-bonding and anti-bonding orbitals when you're filling orbital. It's reset time for 30 minutes. Using LCAO approach, that's how bond order and stability is determined. For NO, total electrons is 15 electrons. Nitrogen, oxygen, nitrogen. Okay. Two, five electrons. Why? Why do we consider? I thought we were considering valence electrons, molecular orbital filling, heteronuclear diatomic, roughly like O2, molecular orbital diagram. Electrons in bonding molecular orbitals. Bond is stronger than double bond but weaker than triple bond. Okay. Now I'm starting to confuse the pi bond and this anti-bonding also what is this anti-bonding orbital? Why is it not like bonding orbital? What's the difference between the electron in bonding orbital, anti-bonding, which makes it not work as we wanted? Let's carefully distinguish pi bonds in covalent theory from pi anti-bonding molecular orbitals in molecular orbital theory. They are related but different concepts. Bonding versus anti-bonding. Bonding orbitals formed by constructive interference of atomic orbitals when they combine. Okay, new terms. Constructive interference. Electron density increases between the nuclei, holds the atom together, lower in energy than original atomic orbital. Lowering energy results in stable bonds. Electrons here stabilize the molecule. Okay, anti-bonding formed by destructive interference. Electron density is low between the nuclei, often with nodes. Plane of zero electron density between them, higher in energy than original atomic orbital. Electrons here destabilize the bond because they reduce the net attraction holding the nuclei together. Electrons here destabilize the bond because they reduce the net attraction holding the nuclei together. Many, 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 many. It's bonding electron cloud concentration between nuclei stabilizes anti-bonding electron cloud outside the nuclei, weakens bond. Destructive interference. So, could you explain this on the wave and particle nature? Electron. Electrons here destabilize the bond because they reduce the net attraction holding together. How? Higher in energy than original. Okay. I understood why the anti-bonding orbital. The anti-bonding orbital is requiring higher energy, which is the opposite of what a bond requires. Golden brown texture. Electrons as waves. Electrons are not just particles, they have wave properties. When two atomic orbitals combine, their wave function act together. Constructive interference bonding orbitals. Wave amplitudes reinforce each other between the nuclei. High electron density between the nuclei. Stabilize destructive interference. Amplitudes cancel each other region between the nuclei. Zero electron density appears between nuclei. Electrons here cannot stabilize the bond. Even though we think of electrons as particles, electrons spend more time in the region between the nuclei. Kept away from the less attractive pole, nuclei can repel each other. Particle resist the bond, higher potential energy. Electron density between the nuclei. Nuclei repel each other because negative charge of electron density cannot shield them. Negative charge of electron density cannot shield them. Negative charge of electron density cannot shield them. Okay, nuclei are positive. They're positive spheres, or let's consider them as positive spheres. Uh, the negative charge cannot shield. So here nuclei has more power or more positive power, so they're repelling each other, and electrons negative charge is not enough to pull them together. Electrons in this orbital cannot contribute to stabilization, so system is higher in energy. In short, bonding orbital equals constructive wave interference, destructive wave interference, destabilizing, higher energy. Can I lift my left eyebrows? No. Oh, fuck me, bro. It feels so weird not being able to control this. Bonding orbital, anti-bonding, okay. Okay, I kinda get it. I kinda get it. A large SP, 2S, 2P interactions. Small 2S. So... Okay, in the case of neon. Okay. Now... Molecular orbitals from 2p atomic orbitals. Adding two 2p orbitals along the internuclear axis proceeds. Adding two 2p orbitals along the internuclear axis produce a bonding sigma 2p and anti-bonding sigma star 2p orbital. Adding 2p x orbitals perpendicular to the internuclear axis produces a bonding pi 2p and anti-bonding pi 2p orbital. Adding two 2p y orbitals perpendicular to the internuclear axis produces another bonding pi 2p and an anti-bonding pi 2p orbital. What? Oh, Josh, don't keep on reading. When you read, process, please. Process. Don't waste time reading that if you don't process it. What is this? 2p. So if there's a positive and negative anti-bonding, 2px. X, yeah. Wait, z. These are bigger metallic bonds. Okay, we got the metallic bonds. Dude. Okay, I got just a little bit more. Come on. When two atoms combine, each atomic orbital forms bonding molecular orbital, lower energy anti-bonding. Electrons fill molecular orbitals according to Aufbau principle, Pauli's exclusion principle, Hund's rule, maximize unpaired spins in degenerate orbitals. The fuck is this? Oh shit, did I just waste some time? I did. 2s2p interactions, large 2s2p interactions. The sigma 2s and sigma star 2s mixed with sigma 2pz. Sigma 1s greater than sigma star, less than sigma star 1s, Less than sigma 2s, less than sigma star 2s. Okay, what is this diagram with the bonding and anti-bonding called? Let me search that up. 30 minutes? God damn it! Damn it! The diagram is called molecular orbital diagram. So I need. That's for fucking O2, boy. 2s, 2s. Bonding, anti-bonding. 2p, sigma 2p. Uh, elite ball knowledge. The bond order tells you how strong and stable number of electrons in the bonding orbital. So it's like 2, 4. Okay, can you? Bum, 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 bum. Oh, it's been a while since I touched this guy. And I'm talking my holy Bible, okay? I was talking about my holy Bible. Bro, it's been a while. Mm-hmm. 10 valence electrons. Wait. Mm-hmm. Mm-hmm. My spotlight is fucking gone. It's not working again. Well, I guess it's time to end the stream. It's been 1 hour. I gotta cook something and I gotta apply for jobs. I gotta do sequence analysis assignment. I gotta do biochemical kinetics assignment. And I gotta complete this thing ASAP. I gotta complete metallic bond, chemical bond today. Then properties of gases, properties of liquids and solids. Dispersion, force, dipole, ion dipole, viscosity, temp, vapor pressure. Then it's redox reaction. That's something I know. Thank God. Chemical equilibrium of prepared solution. That's more. Acids and bases. I feel like I need to speedrun. Speedrun. Well, yeah. YouTube, I'm in the stream. Till next time. That is gonna be in 1 hour or so. Peace. Peace.